So given the function 2x squared minus 9 over x squared minus 4, we want to find the critical numbers. So remember the critical number of a function, we need to solve when f prime is 0, or we need to look for the domain of f prime, sorry. So here we need to solve f prime of x equals 0, and we need to look at the domain of f prime to find where the derivative does not exist, because the critical numbers are two type of points where you have a horizontal tangent line, that's where f prime is 0, or where the derivative is not defined. So first thing we do, we use we're going to take the derivative. So here it's a division, so we're going to have to use the quotient. So it's low d high, so the derivative of the top, so it's 2 times x squared minus 9. The derivative of 2 times x squared minus 9 would be 2 times 2x minus high, so 2 times x squared minus 9 times d low. The derivative of x squared minus 4 would be 2x over low squared, which is x squared minus 4 squared. We're going to clean it up because we're going to have to solve an equation. So this is 4x, this is 4x, and I'm going to distribute 4x throughout. And the same thing here, this is a 2 and a 2, so again that's 4x, and we're going to distribute throughout. So we get 4x times x squared is 4x cubed, minus 4 times 4x is negative 16x, sorry. And again, it's 2 times 2x, that's 4x times x squared is going to be 4x squared, but there's a minus in front, so it would be minus 4x cubed. And then negative 2 times negative 9 is 18, times 2x is going to be 36x, all over x squared minus 4 squared. So here f prime of x, if we combine like terms and everything, you see the 4x cubed and the minus 4x cubed canceled, and we are left with negative 6, so this one and this one canceled, and we're left with negative 6x plus 36x, which is 20x, over x squared minus 4 squared. So now we need to figure out where the derivative is 0, so we set this equals 0. A fraction is 0 means that its numerator of 0, because if you cross multiply, you get 0 times x squared minus 4 squared, that's going to be 0, and you get 20. X times 1 is 20, so it's the same thing as 20x equals 0. So again, a fraction is 0 if its numerator is 0, and so that gives us x equals 0. So that's the only critical number that we have where the derivative is 0, meaning you have a horizontal tangent line. We also need to find where f prime, the domain of f prime. So this is a rational function. The domain will be all real number except where the denominator is 0, so we need to check when the denominator is 0. And this is equivalent to when x squared minus 4 is 0, and that's x squared equals 4, so x is plus or minus 2. So the denominator will be 0 at 2 and negative 2, so the domain is going to be all real number except 2 and minus 2. In addition, we see that 2 and negative 2 are not part of the domain of f, because again, this is a rational, and similarly here, f will be 0 in the denominator when x are both plus 2 and minus 2. So they are not, but they are a point of interest. There's a break in the graph here because the function is not continuous. So technically, the only critical number we have is 0. because x equals plus or minus 2, not also in the domain of f. So if 2 and negative 2 were in the domain of f, then you will have those two extra critical number. But because they were not in the domain, again, the critical number of a function, at those points the function needs to be defined. And the function itself is not defined at plus or minus 2. So even if the derivative is not defined there, the function itself is not. So that's why it's technically not a critical number. So the only critical number you have is x equals 0. And then we ask, use the first derivative to find whether the critical number you find is a relative max, a relative mean, or neither. So here we only have one, so we're going to use again, we have 0. And again, technically if you want to, and we don't need to do that because we literally just looking at if we have a max or a min. At 0, we don't need to look at interval of increase and decrease. We just want to know. So we want to know what's going on before 0 and after 0. But if you were to look at the interval of increase and decrease, I will also put the 2 points where the function was not defined because it's not continuous. So you will technically have 1, 2, 3, 4 interval to check. But here I just want to know if 0 is a critical the critical number at x equals 0 is a max or min, local or relative, same thing. And that means I need to know the direction of the function right before and right after. So I'm going to look at what's the direction. That means, is the slope of the function positive or negative? And for that, we need to look at the sign of the derivative because the derivative represents the slope of the function. So here I'm going to pick a point to the right. So I'm going to pick -1. And then I'm going to take, to the left and then to the right. So I'm going to pick what's going on at -1 and at 1. And here, if remember, this is the derivative is 20x over x squared minus 4 squared. So I'm going to plug in -1 into the derivative. So this is minus 20. And then this is -1 squared is 1. Minus 4 is -3, but squared is going to be positive. So here you have a negative number over a positive. Again, I don't care about the value. I just want to know, do we have a positive or negative slope? This is a negative slope. And similarly, if we do at x equals 1, if we evaluate the derivative here, we are in a situation where we have 20 over -3 squared. So again, it's this time a positive over a positive. So that means the derivative is positive. So remember, positive derivative means positive slope. Negative derivative means negative slope. And so here, if I were to draw what's going on here, the function is decreasing and then increasing, right? So this is f. And so you can see right there you have a local or a relative minimum because it's the bottom of a cusp here, of a valley. If you wanted to know the interval of increase and decrease, I also will have to check what's going on here and here. So I will look at pick up text point to the right of negative, so to the left of -2 and to the right of 2. And you will see again, I'm not going to say if you're curious, if you look at this is negative, this is positive. So technically here, again, how would I figure it out? I look at what's going on at -10. And at 10, and if I do that, I'm going to have -200, and the denominator is always positive because it's squared. So you can see here the function actually is decreasing from -infinity to 0, and then it's increasing from 0 and on. But to answer the question I had was just local relative or mean, and that's at x equals 0. So that's really answering the question. We were not asking for interval of increase or decrease, so I didn't need to do what I did in blue here. I was just looking at what was the slope of the graph before 0 and after 0. And I saw that the function was decreasing and then increasing, so that's why you have a local or relative minimum.